Hello, everyone, and welcome to the AWS Serverless Workshop featuring ClearScale. We're going to give just another minute for everyone to log in and get situated, and then we will get started. So thank you again for attending and looking forward to going through this workshop with you. All right, welcome to the AWS Serverless Workshop featuring ClearScale. I am Jay Martin, essentially your host and air traffic control for the next few hours. As you likely already know, this interactive lab will provide a working understanding of AWS serverless services, such as Eventbridge, Lambda, and AWS Step Functions. This is absolutely interactive, so please utilize the chat function to pose questions, ask for support, or simply acknowledge the great information from our team. As you can see in the panel, we have our chat area, polls, which we're going to utilize towards the labs, and then handouts, where if you need to leave early, I highly suggest downloading the various pieces of content provided and even scheduling a meeting with our team as a follow-up. We have brought in a massive and wonderful team of experts standing by to assist you at all times, so please don't hesitate to reach out, including a trio of solutions architects tasked with presenting. Those would be Robert Bryant of ClearScale fame, Mark Richmond from AWS, and Sam Folks from AWS. As previously mentioned, we do have a bevy of talent ready to assist you, so no question is too big or too small. If needed, they can also directly message you in the system to provide a more private and exclusive conversation. Before we get started, Robert, if you would please give yourself a quick introduction and provide your role at ClearScale.
Sure. I'm a solutions architect here at ClearScale. I've been here for about 3 years, working out of the Houston, Texas area. And I primarily work with migrations, both in a pre-sale and a delivery capacity. As part of that, we often work with customers on application modernization efforts and work around serverless and event-driven architectures and helping customers implement those. So looking forward to going through the workshop and listening to the great content we have here today.
Thank you, Robert. Now let's go over to Mark Richmond, where he can introduce this AWS that I keep hearing about.
Thanks, Jay. Hey, everybody. I'm Mark Richmond. I'm a senior solutions architect here at AWS, and I specialize in serverless computing. So quick plug here for serverless. I really think it's the best way to build and run applications and services, hands down. You don't have to manage infrastructure. Developers, if we have a lot of developers here in the workshop today, I suspect we do. This is great, so you can focus on your core product, reclaim some time and energy that could be spent on developing some great products which scale and are reliable. My customers, they love working with partners like ClearScale. They help accelerate your serverless projects. They follow best practices for AWS services, and they have proven success delivering services to my customers. So please reach out to them if you have any questions after this, and I hope you enjoy today's workshop. Jay?
Excellent. Thank you, Mark. All right. Well, today we have a three-pronged approach to our workshop where we're going to start at the beginning of your journey and then lead into a lab focused on Eventbridge, followed by an exploration of AWS Lambda with a lab followed as well. And then we're going to look at a few real-world examples of how ClearScale has helped a pair of companies on their serverless journey. And finally, we're going to wrap up with a Q&A portion. So again, please fire away at that chat throughout the presentation with your questions. We are exceedingly excited to have everyone here. So without further delay, I'm now going to pass it back to Mark, who will captain this ship on our journey to event-driven architectures. It's all yours, Mark.
Thank you. All right, so let's hope the demo gods are in my favor today, and all goes well. So, all right. So thanks everybody for joining. We're going to talk about event-driven architectures here on AWS today. And so really the crux of this is that, applications, they're the backbone of businesses that span the entire globe. Sometimes those applications hop between multiple clouds and they break down data silos. The continuous state of change means that legacy architectures aren't capable of meeting the needs of the types of modern applications that we're building. So these modern applications, they need to be able to run 24/7, multiple nines of durability, and they need to be highly available, super elastic, and of course, cloud native. So that's good. We've all heard and given that pitch before in one form or another. But why can't we architect our applications using just, say, a bunch of EC2 instances or virtual machines in the cloud? Being in the cloud, we can run 24/7. We could be durable. We could be highly available. And that seems all really simple, right? But we all know that that same three-tier architecture that we've been working with for so many years can't solve for every use case. So we need to be purpose-built for the problem at hand. So we started addressing today's problems with microservices, IoT, cloud, machine learning, and so on. And microservices are great, but when we start having microservices calling each other using synchronous calls, then we start pushing the problem elsewhere. So we're effectively creating a distributed monolith. Uh, and at some point, you'll realize the obvious here. The common element among all these modern problems revolves around the notion of real-time events. So it's these events that drive actions and reactions and transform between different streams and so on. And so event-driven architectures were born. All right, so this may seem rudimentary, but what exactly is an event? In the simplest terms, an event is a signal that a system state has changed in some way. So events are immutable. They can't be changed or deleted. They're ordered in the sequence of their creation. Systems can be notified of changes by subscribing to events, and then they can act on them using some business logic. And we refer to events as having semantic intent. They're represented as verbs in the past tense. So you may see an event something like order created in, say, an e-commerce system, for example. And events representations are lightweight. So they include common properties across business domains, some kind of identifier that refers to some more detail at the source of truth. And we'll see concrete examples of this in just a bit, but we right now just want to level set with some terminology. Okay, so how do you start doing event-driven architectures? Well, it all starts with what we call the domain. So what does a domain mean? It's what we call the business logic and business events, which refer to the higher level rules that model how the business objects interact with each other. So this is really a very natural way for anyone in a company to think about what's happening in their organization. Business events are a form of discovery within an organization, and they communicate what data is available for other organizational units to process. So typically the process to model these events for software developers is to sit with the domain experts, the subject matter experts, in some kind of working session where they start by listing out all the domain or business events. So you'll see some of those events here. And once the software developers sit with the domain experts and start to discover these business events that make up the domain, it becomes easy to design the system because now everyone is speaking the same language, the language of the domain. Okay, so how do you discover what these business events are? So you may have heard about this term called event storming. And event storming is typically a workshop format used to uncover and understand the domain of a software system. It's intended to be lightweight, typically a bunch of sticky notes on a wide wall like you see here in the picture. The idea here is to bring together developers and domain experts in a fun way so they can learn from each other. It's usually fun anyway. I've seen it get a bit contentious, but that's the fun part, right? Okay. So after the events and commands are discovered in that session, the events are mapped to business domains using what we call bounded contexts. And a bounded context is a logical boundary between organizational units. So that's represented by these rounded rectangles here. We have a retail bounded context, fulfillment and support bounded contexts in this example. And you might have already guessed that bounded contexts are similar to microservices. So this is a central pattern in domain-driven design. All right, so let's take a closer look at how a bounded context could generate an event. So let's say, for example, the retail bounded context receives an order. The retail bounded context can perform its series of steps, like generating an invoice, checking against stock, and so on, and then publish an order created event. This event is then of particular interest for several other bounded contexts. And we can use AWS step functions to manage sequencing, error handling, retry logic, and state for the business process. And this process is called orchestration. So between bounded contexts, the idea of event-driven architecture is to choreograph events using subscriptions. So the publishers of events are responsible for sending events to well-known locations. After the event has been successfully sent, the publisher has no expectation for who will receive the event or how it will be processed. This is called choreography. So choreography is an approach to execute different independent events in a specific order. So when we talk about event-driven architecture, we tend to use the term choreography as an approach to execute different independent services in a specific order. Depending on the event type or event data, different services will be triggered and different types of work will be done. And you can think about events as extension points in your application. So when you want to add new functionality, in many cases, you don't need to change any existing services. You can just subscribe to one of your existing events and execute new logic to address your new business need. And events add flexibility to your architecture and they simplify new feature development. So just a quick note on events. They're what we call observable, not directed. So as you can see here, the retail domain sends an order created event. Then the microservices perform their own orchestrations to implement their business logic. So what are the benefits of observable events? So first, event producers don't need to have any knowledge about who's listening to those events. This keeps them simple, and it allows other services to consume events without needing any upstream changes. Adding new consumers becomes quick and easy, and ultimately, this is about decoupling services from each other very efficiently. Okay, so we talked about domain-driven modeling with events, and now we need to talk about event routing. So why do we need an event router? So imagine we have just two microservices in, say, an e-commerce application, which is rarely the case, but this is just a toy example for this lecture. But here, where the order service and the fulfillment service consume each other, we can keep it simple with a direct post of events between those services. But this can quickly get complicated if, say, new consumers also start producing events for other consumers. So just getting a little more complex here. But what happens if we add more consumers as a result of expanding our business? It can quickly get super messy. So the order service now has to be updated whenever a new consumer is added to the system. And the whole point of agility can quickly get lost in this model. To take it to an extreme, it could look like this. So it gets even worse if those new consumers also start producing events for other consumers. So how do we extricate ourselves from this? So the ideal solution to this is to have an event router where the producers can push events to the router and they don't need to know who would be consuming those events. So the consumers would just subscribe to the events of interest to them. And this solution achieves all the benefits that we talked about earlier. All right, so let's look at how event-driven architectures drive overall reliability and scalability. So when you build serverless event-driven architectures, you should think about event sources and how serverless functions can be activated. Events are asynchronous, so you don't need to wait for a response to move on to the next step. And this improves resilience and reduces dependencies. And one of the main components of event-driven architectures are routers that abstract producers and consumers from each other. So you can publish to the router or consume from it without knowledge of other producers or consumers. So the event routers at AWS include Eventbridge and SNS, and we're going to talk about those a bit more later. Event stores, those act as buffers, and they hold on to events until the consumers are ready to use them. And at AWS, SQS, or the Simple Queue service, is our serverless event store, or queue. And Amazon MQ is another service, and it uses standard APIs and protocols that you might already be using and familiar with, protocols like AMQP, STOMP, MQTT, and WebSockets. All right, so let's take a look at what choices we have here for event routers. So if your customers want to go AWS native, then we have SNS and Eventbridge. But if they already have something like ActiveMQ or RabbitMQ, then Amazon MQ might be an option in the cloud. And let's take a look here at how Eventbridge works. So how was Eventbridge born? We started off with CloudWatch events and then enhanced that service since we started seeing the power of event-driven architectures. So essentially, you can create event buses within AWS accounts that route events from event producers. So event producers can be AWS services or third-party producers like Zendesk or New Relic or Datadog, and there are many others that you'll be familiar with. And you write rules that match incoming events from those services and route them to targets. So a single rule can route to multiple targets, all of which can be processed in parallel if you like. And a target is something that just processes an event. So you can have up to 5 targets per rule. And it's really easy to have multiple microservices consume the same event, or only certain microservices interested in an event. So using such event-driven architectures, the amount of code that you have to write is significantly less. All right, so the anatomy of an Eventbridge event. So you can see this is a JSON structured payload with some metadata and then the actual payload. So you can create rules to match really anything in the structure. And all events have these top-level fields, right? So that's the envelope metadata. Say here, version 0 is for all events. And this is the ID here. That's a unique value generated for every event. And that can be helpful in tracing events as they move through various rules to targets and then get processed. You see other values here like detail type. You can see this is a new order. And this, so these help identify in combination with the source field. Here is the order service, the different fields and values that appear in that detail field. So the source, this identifies the service that produced the event, and then in the details in the payload, you could see order ID, customer ID, and then any other data that's relevant to this event you can include in the event payload. All right, so in this example, this is an order created event. So this is a JSON structure that contains all the details related to the order that we published to the Eventbridge service. So this is in our fictitious e-commerce system. But you don't have to deliver all your events to all your services that subscribe to your Eventbridge bus. So what do we mean? What do we mean by that? So using Eventbridge, we can easily filter events and send only specific events to the downstream services based on event attributes and data. So in this case, we want to filter the event based on the detail type attribute value. In our case, it's order created, and we only want these 3 services to receive it, the ones with the arrows pointing to them on the right side of the diagram there. So in the future, if say we decide to add something like a loyalty program, for example, instead of rewriting the application or changing the order service, we could just add a new filter rule to Eventbridge. So if there's, say, a member ID in the event, for example, we'll send that event to the loyalty service for processing. This allows us to choreograph the flow of events in the system and maintain the boundaries between our various services. So unlike the traditional monolith architecture, this approach is much simpler to implement, and it's really just cleaner overall. Okay, so we have a number of rule primitives in our Eventbridge rules, and using these rule primitives, you can construct some rather advanced rules. So you have your null rule. So you want to see if a user ID is null. Whether it's empty, which is a distinction from null, equality, logical and, logical or. So these are your Boolean logic operators. And then we have some additional operators that provide functionality that's similar to what you might use in, say, an SQL where clause for filtering records in a database. So exclusivity, so not, numeric equality, numeric range, if something exists, does not exist, or begins with. So with all of these different operators, you can compose really complex rules if you like. Okay, so as the complexity of your architecture grows, you'll begin to ask yourself questions like, say, how do I describe and version events? Or how do I enable my development teams to easily discover events in my organization? Or how do I increase developer productivity and do that while maintaining consistency across different implementations? So that's where something called Schema Registry comes in, and you'll see that in the top center of the diagram. Schema Registry allows developers to define the event structure or schema using a standard specification like Open API, and now also with JSON schema. So this removes the need for developers to have to look through documentation, and it allows them to consume and validate events programmatically. So the Eventbridge Schema Registry makes accessing schemas easy by centrally storing schemas generated by all your different event sources, so any developer in your organization can access them. When the schema registry, when the schema discovery service feature is turned on, all the events in your buses are sent to the registry, so there's no need to create the schemas manually. It's going to automatically discover them. But of course, you have the option to do that, and we provide you some templates as a starting point. Those schemas can also be used to download code bindings, which allow you to represent the event as an object in your code. And you can take advantage of IDE features like validation and auto completion. So there are plugins for VS Code, JetBrains, other IDEs. And you could download those code bindings for different programming languages, so Java, Python, TypeScript. A lot of flexibility there. So let's take a look at a customer use case. So Lego, everyone knows Lego. Lego builds with an event-driven design, and they do it nearly all on Eventbridge. So Lego is an AWS customer. Back in 2017, Lego had a monolith architecture. But after a Black Friday sale crashed their entire system, unfortunately, they were looking for something that was more scalable and resilient. So they began decoupling their backend and building an event-driven serverless application and succeeding. So July 10th, 2019, they announced that Lego was serverless on AWS. And the very next day, July 11th, we launched Eventbridge. So Eventbridge was perfect for the kind of hub and spoke event bus model that Lego was trying to achieve. And so Lego rebuilt their whole checkout event processing also with Eventbridge, and that's illustrated here in the diagram. This way, rather than using, say, point-to-point connections between services, they have a much simpler way to operate their events. So that is Eventbridge, and we are going to go right into our first lab with Sam. So event-driven with Eventbridge.
Excellent. And Sam, while you are getting ready for that, I did want to present a quick poll. In each of these workshops, we find that the experience is a little bit different for the attendees. So we want to know how you would prefer the lab presentation portion be displayed. Will you watch and follow along step by step as Sam kind of explains each and every piece? Would you prefer to have complete silence and just have Sam kind of work through it in the quiet? Or would you prefer Sam kind of have a couch conversation, as we've called it in a couple of other workshops? So we'll give you just a couple of seconds to determine how you would like to handle this. Certainly for those that want the absolute silence and work at your own pace, you can always mute or lower the volume on your computer so it's less of a distraction. We do have about 45 minutes to walk through these labs. Actually, a little bit more than that because Mark so finely went through his presentation. But it definitely looks like, Sam, you will be being our full captain on this walkthrough. So let's go ahead and continue here. And Sam, take it away whenever you're ready.
All right, sounds good. Thank you, Jay, and thank you, Mark, for taking us through the presentation so quickly. So right now we're going to go through the first lab, which is building event-driven architectures on AWS. Now, I believe the link to that walkthrough is actually pinned in the chat. Yes, it is. So you should see a link. Event-driven-architecture.workshop.aws. It's pinned in the chat, so if you could navigate to that link, we'll get started. So before we jump in, I'm Samuel Folks. I'm a Senior Solutions Architect at AWS, and I am going to be guiding you through the labs that we're doing here today. The first one is going to be focusing on Eventbridge, which Mark just ran through just now. But before we do that, we're going to go through the setup of our tool called Event Engine, which is going to allow you to actually set up your AWS account to actually go through these labs. So let's click on getting started here. And we go to Event Engine. So we're going to need to log in. So if you're following along using the link, the workshop link, there is a link here to open the Event Engine dashboard. So we're going to click on that link. Actually, let's just, if you navigate to dashboard.eventengine.run/login, you should be presented with that screen. Now, you should have been given a hash code before you or upon signing up for the workshop. And what we're going to do is we're going to enter that hash code here. So let me go ahead and enter my hash code.
And just to clarify, that email was sent out by Big Marker, which is the platform obviously we're using right now. That was in an email about 30 minutes prior to the start of the presentation. You can get the hash code there, although we do have it readily available also in the chat if you just want to grab it there. But it's a team code, so everybody will be using the same hash today.
All right. So we're going to enter the hash code, and we're going to go ahead and click Accept Terms and Login. And you should be presented with a screen that gives you multiple sign-in options. Now, of course, I'm going to select the Amazon employee option because I'm an Amazon employee, but you have the option of using your retail Amazon account, as Amazon.com account, or you can use your corporate email, and you will actually receive a one-time password, which will allow you access into the Event Engine tool. So I'm gonna here. Now, upon successful login And I'm not gonna go too fast. I'm gonna give you all a few seconds to actually get through the login process. But I'm gonna talk through some of the things you'll see on the screen. So you'll be prompted with a dashboard which contains a link to the AWS console, which we'll be using today. And there are some other links for some support services that we're going to be using, to go through the lab. That's the support service we're going to use is called the event generator, and we're going to actually use it to generate events for demoing or Eventbridge. So let's actually set up this event generator first before we actually start going through the lab. So if we, and I suggest that rather than doing everything in one tab, if you're able to, just open these URLs in different tabs, so you can actually just switch between tabs. It makes for a faster and smoother experience. So I'm going to copy this URL here. I'm going to paste it into a new tab. So you'll be prompted with a user pool configuration page, and the settings that are pre-populated should already be fine. So you can just go ahead and click configure. And then you'll be prompted with a sign in page. So what you're going to do is take the username and the password that was generated on the team dashboard. So the username that you get should be user. I'm just going to go ahead and copy this password here. And I am going to sign in. Right. So we're actually going to be using the event generator for Eventbridge today. So we can just leave this as is right now and head back over to the team dashboard. At this point, we're going to click AWS Console, and we're going to open the AWS Console. Please note this reminder here to just ensure you're using US East 1 as your region. Okay, so I'm going to pause here for a second and just check if everyone is on the same page, if we're all caught up to the same point. We all should be in the AWS console right now.
And Sam, I just posted another poll just so we can find out the pulse of everybody, whether they're ready for the lab or if they are still working on logging in. So we'll give people another minute. It looks like 50% or so are still trying to log in.
Okay. Please, utilize the chat to ask questions if you're stuck. Okay, so I'm seeing a question in the chat regarding the OTP. It should actually be sent to the email address that you enter, your corporate email address. Okay, are we all caught up? Awesome. So it seems that we are all caught up. Jose, it seems as if your emails have come through. All right, so let's head back to our workshop page, and we are going to click on event driven with Eventbridge. All right. Now, as Mark mentioned in his presentation, Eventbridge is essentially just a serverless event bus that we use to connect our microservices. All right. It allows for our microservices to be completely ignorant of each other. They don't need to have any stateful links between themselves, because this event bus is actually going to handle the collection and the routing of events to these microservices. So let's quickly run through some concepts again. Mark actually went through these, but I'm going to just quickly go through once more. So an event essentially indicates a change in an environment. It's a signal to your application that some state has changed. All right. Rules. We use rules to actually match incoming events and route them to the specific target that should handle the processing of that event. And a target is essentially just it could be a function, it could be a service. It essentially just processes these events. And an event bus, which is what we're going to go through right now, which is what Eventbridge is. It receives these events and handles the routing of these events to these various services. So again, the event bus actually gives the possibility of having these services that are completely ignorant of each other. So we're going to quickly go to our console now, and we're going to create our first event bus and some targets. All right. So I am going to be switching over to the console in my screen share. So you can you have the option of following me, or you can follow the instructions on the workshop page itself. So the first thing we're going to do is we're going to create a custom Eventbridge event bus called the orders bus, and we're going to create a rule that's going to essentially just match all the events sent to that orders event bus. So please take note of this global search feature at the top. It's very useful. So we're going to navigate to Eventbridge. So we can just go ahead and type Eventbridge here. And what we want to do is to navigate to the event buses link in the left navigation panel. So you should see an orange button in the bottom right of the page called Create Event Bus. We're going to click on that. And we're going to name this bus orders. We're going to leave the permissions blank, and we're going to go ahead and click Create. And we've now created our first event bus. So the next thing we're going to do is we're going to create a CloudWatch target. Now, this target, as we discussed before, is going to actually, receive an event and process it in some way, or it may just list the contents of the event. So on the left, in the left navigation pane, it might be closed for you. Just click that hamburger stack icon to get it open, and we're going to click on the rules link, and we're going to go ahead and click Create Rule. So we are going to call this rule the orders dev rule. And for the description, we're just going to call it a catch-all rule for development purposes. Here we're going to get into the configuration of this rule. All right. So we're going to select event pattern, because we're building a pattern to match events. We are going to select predefined pattern by service, and that's because we're actually using an existing AWS service as the service provider here. We're going to click on all events, and we're going to scroll down, and we're going to make a change here. So we're going to select custom or partner event bus, and we're going to select the orders event bus that we created earlier. Okay, and for our rule target, so what we're going to do here, we're actually sending this event to CloudWatch logs. So our target here is going to be CloudWatch log group. You should actually see that in the long list of possible targets here. And we're going to call this log group the orders log group. Once we've done that, we're going to leave these tags blank in this case, and we're going to click create. All right, so we have successfully created an event bus, and we've created a rule to actually filter these events. Now, the next thing we're going to do is we're going to actually test that this event bus is working correctly, and the rule is actually capturing that event and pointing it at the correct target, which we've defined as a CloudWatch log group. What we need to do is head over to our event generator, which we configured earlier. So because we configured this before we created the event bus, if you click the the drop down, it might not show orders. So just click that refresh icon there beside the event bus drop down, and we're going to ensure that we select orders, because this is the bus that we want to use, and we're going to click publish. And it says the event has been successfully published to the orders event bus, and it gives us an event ID. Now, in order to see that this has worked, we're going to need to navigate to CloudWatch logs. So under features, if you type logs in the universal search, under features, you should see a link here that says logs. We're going to click on that. And we see a number of log groups here. We're going to select the AWS/events/orders log group. And as you can see, we have a log stream here that was created. And if we expand this, we will actually see the event that was published to the orders event bus with the actual event detail here that we had that was pre-populated in the event generator window. Now, let's take a moment here to look at the actual structure of the event. Now, as Mark had pointed out in his presentation, there is an envelope here that contains like some metadata. So we have the event ID, the source of the event, the account number that the event was published in, and the region. And here we have the actual event payload. So if you recall, if you head over to the event generator, you'll see that's the event payload that was entered in the window there, and it's the same thing here that was published as the payload. So we have just configured an event bus, we created a rule, and we were able to publish a test event, and we saw that it was captured and routed correctly to the correct target, which was CloudWatch logs. So before we move on to the next section, I'm going to just pause here and ask if everyone is caught up, and ensure that we're all seeing the same thing, we're not having any issues. Please bear in mind that if you are having issues, make use of the chat. We do have a number of resources here to help you if you run into issues.
And then one other note, Sam, that we can mention is that you will have access to this event engine instance, I believe, until 8 p.m. Veda.
You can access it until 12 a.m. EST.
Well, there you go. So even longer. So certainly you can listen through, go back and do these labs, once more or check things, but you will have plenty of time to work through these labs both today during the workshop and after the workshop.
Sam, there are a couple of questions here. Can you show the rule config again?
Sure. So we're going to head back to Eventbridge. We're going to head to Rules. We're going to select the Orders event bus. And this is the rule that we created. So as you can see, the target here is a CloudWatch log group of the name Orders. And if we go into this, the actual configuration itself, we had selected event pattern under the define pattern window here section. We selected event pattern, and the matching pattern is predefined pattern by service. Service provider here is all events. And when we scroll down to select the targets, we have a CloudWatch log group selected as the target, and the log group is selected as the /AWS/event/orders log group. So you should be seeing the same thing that I'm displaying here on the screen. No, this is actually grayed out, the section that allows you to select an event bus. That's because that can be edited, no, but upon creation of the rule, it was not grayed out, and we selected custom or partner event bus, and we selected the orders event bus that we created. Okay.
And a no, yes. So the source is com.aws.orders. Yes, that's something that you as an event generator can name whatever you want.
Right. So let's quickly look at the event generator section again. So this is the tool that we're using to actually publish these events to the orders event bus. So just please verify that you're seeing the same thing that I have here on my screen. So your event bus, you're going to select orders. Source, you're going to leave it at com.aws.orders. Detail type should be pre-populated. It should say order notification. And here is your detail template. Now, for those of you who are able to do this successfully, you can actually play around with this. You can change some of these, not the event bus or source or detail type values, but you can change the detail template values just to see or test the publishing to see different values. If I were to change this to, let's say, suppose old, change this value to 417. And click publish. This changed event will be published to the Eventbridge event bus, and it will be routed to CloudWatch logs. So if I were to go back to CloudWatch logs, and click on the orders log group, as you see, there's a second log stream here. No, actually, I clicked on the older one. The newer one is at the top, and you can see the new payload that I changed it to just now. So you can play around with that, test different values to see what comes across.
Hey Sam, can you quickly show if people close the event generator URL, how they can get to it?
Okay, so this there's this team dashboard, event engine team dashboard that you would have seen when you first log into event engine. Try to keep this URL open in a separate tab, because all your URLs are here. So you can just copy this event generator configuration URL. It's actually a configuration URL. If you navigate to event-generator.awsworkshops.io, you'll actually see this. I'm going to actually pin this link in the chat here. All right, so if you need to get back to the event generator, you can just access it using that link. All right, so it seems everyone has been able to complete the first step of the lab. So the next thing we're going to move on to is working with Eventbridge Rules. All right, so if you're following along using the workshop link, that's section 2.2 under Event Driven with Eventbridge. All right. Okay, so let's head back to the. All right. So as we discussed before, rules essentially match events and route them to targets for processing. Currently, you can actually have up to 5 targets per rule. So you're not constrained to a one-to-one mapping between a rule and a particular target, right? Now, all of these events, when they get to the target, they're processed in parallel, which is also great because you don't run into issues of incongruous processing of these events. They're not processed in a particular order. All right. So we're going to walk through the steps to create. Well, we already created the orders event bus. We're going to actually send this event to a Kinesis Firehose delivery stream, and we're going to store these events in an S3 bucket. Pretty cool stuff. All right. So these targets, just bear in mind, these targets have already been provisioned for you. So what we're going to do is just look at the rule itself, just writing these rules to match these events and to verify that they have been delivered to the appropriate targets. All right. So we've already gone through, the rule matching basics. We know what the event structure looks like. There's, the envelope metadata here, and we also have the payload. All right. Now, rules use event patterns, and they use these patterns to match the events, to filter them, and then to route them to these targets. All right. And there's no in between. The pattern either matches or it doesn't. If it matches, it will get routed to the target. If it doesn't, it won't. All right. So as an example here, this event pattern says the source is AWS EC2, right? So an event coming from the source AWS EC2 will match this rule and get routed to the associated target that was defined for it. So here are some important things to remember about event pattern matching. So for a pattern to match an event, the event must contain all the field names listed in the pattern. Another thing to remember is other fields of the event not mentioned in the pattern are ignored. So there's effectively a wildcard for fields not mentioned. Matching is exact, character by character, without case folding or any other string normalization. And values being matched follow JSON rules. So, strings are enclosed in quotes, numeric values are not enclosed in quotes, and, keywords such as null, true, and false are all valid. And number matching is at the string representation level. So 300, 300.0, and 3.0 to the second power are not considered equal. All right. They must match at the string representation level. So with that said, let us jump into the Kinesis Firehose challenge, right? So we're going to process all events from the source of the com.aws.orders via a Kinesis Firehose delivery stream. And we're going to show basically how you can create an audit trail of all events from a specified source. All right. And we're going to be persisting them to an S3 bucket, which I had mentioned before. So I'm going to jump back over to the console now. And we're going to head back to Eventbridge. And we're going to select rules in the left navigation pane here. We're going to ensure that we've selected the correct event bus, which is the orders event bus, which we had created earlier. And we're going to go ahead and create a rule. We're going to call this rule the audit orders events rule. And for the description, we're going to send com.aws.orders source events to Kinesis Firehose. All right. So we're going to choose under defined pattern, we're choosing event pattern. And under event matching pattern, we're going to select custom pattern. So if you're following along using the workshop link, you can actually just copy that event pattern, paste it in the section here. As you can see here, source is com.aws.orders, and this is valid JSON. Now this trips people up a lot. It trips me up sometimes. You need to remember to click save. All right. All right. So we're going to move on to the selection of an event bus. We're going to select custom or partner event bus, and we're going to ensure that we've selected the orders event bus that we created. And we're enabling the rule on this selected event bus here. Now to the juicy part, we're going to select our target. So from our drop down here for target, we're going to select Kinesis Firehose delivery stream. And for the stream, we're going to select orders delivery stream. Now again, as a reminder, this was actually created for you beforehand. So yeah, don't be confused about where that the delivery stream popped up from. We are going to select create a new role for this specific resource, and there should be a value pre-populated here, a string value. We're going to leave that as is. We're going to leave our tags blank again, and we're going to go ahead and click create. So we've created a new rule that's basically going to essentially catch all events from a particular source. That's the com.aws.order source, and we're going to route it to Kinesis Firehose. All right. The next thing we're going to do is we are going to send a test orders event. All right. So we're going to jump over to the event generator. And you can just go ahead and click publish again once more. All right. So what we're going to do now, we're going to head back to the AWS console, and we're going to verify Kinesis Firehose. So we are going to, in the search, we're going to open the S3 console. And so we don't have to do too much of a search. There is the bucket here, orders-us-east1. I mean, you may have a different value here for your orders bucket. I'm going to select that bucket. And actually there should be an object here. There isn't. So let's head back and test this event here. So our source is correct. Our event bus is correct. Change this detail here. And click publish. So that should have been caught by that rule. So let's actually go back here and verify that our rule was configured correctly. Should be our audit orders events rule. All right, so we have the correct pattern here. This JSON is valid. Selected the correct event bus. We've selected the correct delivery stream. And we have selected to use an existing rule. So everything looks good here. Is everyone following up to this point? Just indicate in the chat if you've caught up with where I am. Okay, so let's head back here to our S3 console. All right, so there must have been some delay with the publishing, but we have, as you can see, there's an object now in the bucket under the firehose prefix, firehose/prefix. So we're going to drill down. Year, month, day. And I hit publish twice, so we actually have two events here. All right. So we're actually going to, from the actions dropdown, we are going to hit query with S3 select. Let's just select that first. So we're going to set our format here to JSON. As you know, the event is delivered in JSON format. The JSON content type is going to be set to document. And our output settings here, we're going to set that to JSON. And we're going to hit run SQL query. And as you can see here, we have returned an Eventbridge event, complete with our envelope metadata and our event payload. So are we all following? Are we all caught up? Bear in mind that if you enter your S3 bucket and you don't actually see anything there, it can take a little time to actually be delivered to S3. So if you just keep refreshing, you should see it pop up shortly. Okay, so to recap what we just did, we created a rule that basically filtered all events from the order source, routed it to Kinesis firehose, which then, delivered that event to an SV bucket, which, we've seen. So if we're all good, we're going to move on to our step functions challenge, right? Now we're actually going to implement an Eventbridge rule to target, or step the step function service. And the step function service, essentially, it functions as an orchestrator. You can actually use it to build workflows within a microservice. So once more, I'm going to head back to the Eventbridge console. And we're going to hit rules. You guys should be all, familiar with this at this point. We are going to create a rule, and we're going to name it the EU orders rule. So what we're going to do is we're going to select event pattern here, and we're going to create an event pattern to match want to match all events with a detailed location in EU West or EU East. So I believe we had in our Eventbridge, let's see, event generator, sorry. So I had changed mine to US East. I believe, let's see. I believe this location, I think I had changed this to US East. I think before it was EU West or EU East. So, right. We can actually fiddle around with that to actually see what the rule actually detects. So we're going to head back here to Eventbridge. I'm going to use a custom pattern. So we need to actually look closely at this pattern that we're putting here. So I'm actually using the previous pattern that we used for the last challenge as a template. So what we want to do is we want to ensure that the location matches EU West. Let's try EU West. So let's see. And if you're following along on the workshop, there is a sample event that you can reference to actually, look at what the event structure looks like to actually create this custom pattern. Okay, so this is what your event pattern should look like here. Okay, so we're going to go ahead and select the orders event bus as usual. And for our target, we are going to target a step function state machine. And the state machine is order processing. Again, this was all, created beforehand for you. And, we're going to select the checkbox there beside the radio button, sorry, beside create a new role for this specific resource. Again, discard me. We need to click save here on the definition of the pattern. And we click create. So what we're going to do is we're going to head back to event generator. And so like for the location, I had used EU-West. So what we're going to do is we're going to ensure that in a detail template, the event that we're sending has a location of EU West to ensure that it matches that rule. I'm going to hit publish here. And if you're following along in the workshop, there's actually two event payloads that we're going to send. Publish that one as well. And now we're going to verify the workflow execution for our step functions. So we're going to head over to the so actually okay, so our this event pattern that I put in is actually invalid. So let me edit this. One second here. In the interim, let's navigate to the step functions console. We're gonna have to do the publishing again because the rule wasn't actually saved. One second here. While we get that sorted out, are we all caught up? Okay.
Hey, Sam, actually, I think Donald solved it for you. Open curly, location and quotes.
Yeah. Thank you, Donald.
Yeah, thanks, Donald. Thanks, Sarah.
Donald for the win.
Sam forgot to do his ritual sacrifice to the demo gods prior to the workshop.
Yeah, silly me.
The demo gods are angry gods.
Okay, so there we go. All right, so let's republish these events. So there's one for EU East and one for EU West. All right, so now we should be heading to the step functions management console. And we're going to select, well, state machines should already be selected. We're going to select the order processing state machine. Okay, so we have an execution that took place here that succeeded. And we can actually look at the graph inspector here to actually see, you know, how that workflow actually went. And here we have the execution event history. So as you can see, the event was published. It was successfully, you know, matched to a rule and routed to the appropriate target here, which would have been, you know, the step functions. So I'm going to pause here for a second, just, you know, to ensure that everyone is caught up. We have one more challenge, I believe, which is the SNS challenge. We're actually going to, you know, publish an event and have it target SNS, which is our simple notification service. So is everyone caught up and following along? Okay, so I see no objections. So it's I'm going to assume that we're all on the same page here. So I am going to, you know, let's move on to the SNS challenge. So again, I mean, at this point, you know, we all should be able to, you know, do this part in our sleep. We're going to, you know, create another rule, and we're going to use this Eventbridge rule to target SNS. So we're going to hit create rule, and we're going to give it the name US Lab Supply Orders rule. And what we're going to target here is we're going to select event pattern. We're going to select custom pattern, but this time we're targeting the category lab supplies. Okay. Let's just use the same template as before. So we're going to change this to lab supplies, and we're going to change the value to, oh, actually, no, it should be category, and the value should be lab supplies. And we're going to review that, make sure it's fine. We're going to hit save there. Again, we want to ensure we have the correct event bus selected. And we're going to change our target to an SNS topic. And the topic we're going to select here is the orders topic. Once more, we're not going to create any tags, and we're going to hit create. Ensure that gets created successfully. And we're going to head back to event generator, and we're going to, you know, publish a couple of test events. So we're going to publish one with the category lab supplies, and we're going to publish another with the category office supplies. And again, as a reminder, you can actually find these templates, these JSON templates on the workshop page if you're following along there. So we're going to verify our SMS topic, and how we're going to do this is we're going to navigate to the SQS console. SQS is our simple queue service, and this is what we use with our serverless architecture. It's one of the options actually for using a queue. We're going to select the orders queue, and we're going to click on send and receive messages. So as you can see, there's one message available here. We're going to hit poll for messages, and we see our message here. So this is actually wrapped with SNS metadata here. But if you dig through this, you will find the event that we sent, the payload that was sent. So it is all right. So we see the source here. AWS orders, we see category, lab supplies, location. So our payload has successfully been added to the SQS queue via SNS. All right. Okay. So we are going to clean this up by deleting this message, because it's never good to leave messages lingering in a queue. And we have successfully completed the SNS challenge. So just to walk through what took place just now, similar to the previous challenges, we had a rule filter for a particular event pattern. In this case, we looked for an event with the category lab supplies, and that was actually sent to an SNS topic, which from there it was routed to an SQS queue, and we're able to pull the queue and actually retrieve the message. So we see that it was actually successfully routed to the correct place. All right. So we've gone through working with Eventbridge rules, and the next section we're going to look at is scheduling expressions for rules. And before we jump into that, I just want to ensure that everyone is on the same page, and we're not, no one is experiencing any issues, and we're all following along clearly. Just indicate in the chat if you're having any issues, or if everything's all kosher. Okay, so I don't see that anyone has any issues, so I'm going to take that as a sign that we can move on. So just to take us back to the workshop guide, we're going to click on section 2.3, which is scheduling expressions for rules. So basically what we're going to do, we're going to play around with the concept of creating rules that trigger on an automated schedule, using cron or rate expressions. So I saw someone post in the chat earlier, bye cron. Not quite. There's still use cases for cron and rate expressions. All right. So just bear in mind that all schedule events use the UTC time zone, and the minimum precision for schedules is 1 minute. And Eventbridge does support cron expressions, and it supports rate expressions as well. Rate expressions are much simpler to define and understand, but it doesn't give you that granularity that a cron expression would give you, that fine-grained schedule control. All right, so we are going to give this a try. I'm going to head back to the AWS console here, and I'm going to navigate once more to the Eventbridge console. Once more, we're going to select rules. We're going to select the orders event bus, and we're going to hit create rule. And we're going to call this rule orders reconciliation. And give it a description here. So this runs the reconciliation routine on orders every minute, Monday to Friday. All right. So we are going to select under the define pattern panel. We're going to select. Okay, why am I not able to select schedule here?
Did you select the default event bus?
Oh, it needs to be default?
Yeah.
Okay. So
Yeah, AWS services always go to the default bus.
okay.
Yeah, you got to start over, unfortunately.
All right, so we're back to the default event bus. So it's not the orders bus as we did in the previous examples. And we're going to create a rule once more. Let's quickly jump through these things here. And we're going to select a cron expression. So you can actually just copy and paste this from the workshop guide. Okay, so we're going to keep the AWS default event bus as default here. And for our targets, we're going to select CloudWatch log group. And we're going to call this one orders reconciliation. I'm going to leave the tags blank once more. And we're going to hit create. And then we're going to verify our scheduled message delivery. So we're going to head to CloudWatch logs. Logs here under features. And we're going to hit the orders reconciliation log group. So I think this is set to be triggered every minute. So let's wait a bit here. So after a few minutes, we should actually have we should see some log streams being populated here. All right, so we have one event sent here. And if we expand, we'll see our our event JSON here with our metadata and our payload. All right. And we just very quickly and very simply created our first scheduled expression for an Amazon Eventbridge rule. So we would have just gone through the entirety of the Eventbridge lab. We looked at some of the features of Eventbridge. We looked at how we can accomplish certain things. We created our first event bus. We created targets. We looked at how we can route events to various targets. We routed events to CloudWatch logs, routed events to Kinesis Firehose, SNS, etc. And we also looked at creating custom patterns, and we looked at scheduled expressions for rules.
Excellent. Thank you, Sam. I did just post another poll just to gauge where everybody's at. Certainly, we can give people some more time before we head into a brief break. So I don't mind waiting for 5 minutes, and then we'll go to a 10-minute break. Certainly, if you are already done with this portion, you can take your break a little bit early. but we'll be looking at jumping back in, roughly around 12:45. So for the next 5 minutes, we'll just be answering any questions you have via chat, and then I will post a 10-minute countdown clock so that everybody knows where we are in our break. All right, I don't see many comments coming in through the chat right now, so what I'll do is go ahead and post our break. It'll be a little bit longer than 10 minutes. We're looking at roughly 13 minutes after I post it, which puts us at 12:45 my time, but the 45 mark of your hour. So we'll be back in a little bit for the second half, where we'll be talking about AWS Lambda and working through those labs as well. So thank you for staying with us. Certainly, if you are on a time crunch, please do make sure that you grab some of those handouts and download the presentation and that sort of thing before you leave. Otherwise, we look forward to jumping back in with you here in roughly 13 minutes. Thanks, everybody. All right, our break is now over. So hopefully you were able to take some time, get some coffee, grab a quick bite of lunch, and now we can jump right back into it. So I know we are not necessarily doing the full SNS piece, but it is within the presentation. So Mark, if you just want to give a high level of what's included in the presentation, and then we can jump over to the Lambda portion of the overall presentation.
Yeah, sure. Thanks. So we did cover Eventbridge. I think you're all well on your way to being experts by now. So alternatively to Eventbridge, you can use SNS, which is our simple notification service, or our publish subscribe pub sub service. So at a very high level, just like Eventbridge, it can enable event-driven architectures, but unlike Eventbridge, SNS has much lower latencies. It can scale to operate on large volumes of messages, and it can also integrate with SMS and email targets. So I think Jay. So we're going to be skipping over SNS and just go right into Lambda.
Certainly up to you based on the time. If you planned on going through this entire portion of the deck, we can certainly go through it now. But I know that we're not doing those labs, so.
Yeah, I think we can get through it pretty quickly because there actually isn't as much Lambda content. So I'll just talk faster.
Sounds great.
Okay, we'll be fine on time. All right, so like I mentioned, SNS. This is our pub sub service, so publish and subscribe, and it's for lower latency applications than what you could accomplish with Eventbridge. Okay, so by default, SNS subscribers receive every message that is sent to a topic. So say you consider a situation where you want to handle US orders and EU orders separately in this fictitious e-commerce system that we're working with here. So if you use the default setting, the responsibility of sending the message to the right topic would be on the publisher, which really isn't what we want. So the idea behind an event router is to have publishers send messages to the router and have the logic within the router to send to the right consumer. And that's what we learned with Eventbridge. So to solve for this routing, you can use filters in SNS, just like the rules in Eventbridge. So you can assign what's called a filter policy, which works like a rule. And this is just a JSON object containing attributes that define which messages the subscriber receives. So very similar to what we saw in Eventbridge. We have some message filtering operators. So again, very similar to what we had in Eventbridge. This is a filter policy that allows you to specify attribute names and assign a list of values to each of those names. SNS will evaluate these attributes against the subscription filter policy, and it'll ignore any attributes that aren't in the policy. So any topic subscription that includes a filter policy can selectively accept or reject a message. So analogous functionality to what you see in Eventbridge, and you have this in SQS as well. You can also use numeric values to match message attributes and filter messages. So either exact matches or ranges. We saw this with Eventbridge as well. And so that's it for SNS. I told you I'd be quick there. Another service that I want to touch on briefly is Amazon MQ. And again, we're also not going to be covering this in the lab portion of today's workshop, but it's worth noting. So for customers who want to remain in the open source implementation or are already using active MQ, we have the option of moving to managed MQ service. So it's not completely serverless like SNS and Eventbridge, where customers are billed in terms of individual messages. MQ is more of a managed service. So generally, it's more appropriate for customers who are in the open source ecosystem. All right, so following our path here, so we understand our domain. We've chosen an event router, so we either chose Eventbridge or possibly SNS, and then we need to pick what's called an event store. This is the persistence mechanism for each event. So until now, we looked at choreographing events between microservices. And when events are delivered to microservices, what if the delivery is too fast for the microservice to process the event? So event stores come in handy at this point where you can buffer messages and control the rate of the incoming events as they arrive. So we generally have two types of event processing models: message processing and stream processing. So message processing, an individual message is our core entity where we apply some processing or compute. And it could be a financial transaction or a command to control, say, an IoT device. And the occurrence of messages typically varies. In stream processing, the stream of messages is our core entity. So only by looking at many messages together, we get the value out of each individual message. And stream of messages is also constant in most cases. So common characteristics for message processing are that you can configure after how many unsuccessful attempts to process a message, the message should be moved into what we call a dead letter queue, or DLQ, where you can process the message out of order. Typically, a message will be deleted by a consumer after the message was successfully processed. And this means that there's no need to track which message was already processed by a client. The client is just asking for the next one, which is typically the oldest message that the message broker has. Contrast that with stream processing. In stream processing, each client maintains a pointer to a particular position in the stream. So after you've consumed a message, you don't delete the message. You simply move the pointer forward to the next message in the stream. So it's important to understand that each client has to maintain its cursor, that pointer, in a durable way. So, for example, storing that in something like Amazon DynamoDB. When you're using Lambda with Kinesis data streams, this heavy lifting of pointer management, that's all handled for you, so you don't need to think about it. You should pay special attention to how you handle what we call poison pill messages. If your client is constantly failing to process a message, it gets stuck at a certain point in the stream and it can't move on. So that could be because like a malformed message or some error in your logic. A common solution is to put these messages into an SQS queue and then handle those out of order. All right, so we have so many different event store services to choose from: SQS, Kinesis, MQ, Managed Service for Kafka, MSK. How do you decide which one of these to pick? So we'll touch upon SQS and Kinesis since they're popular in serverless architectures. Lambda has really good integration with both SQS and Kinesis. The Lambda service has built-in pollers which poll the SQS queue, and it delivers messages in batches to your Lambda function. Lambda starts with 5 threads of pollers, and it adds more concurrent functions every minute to keep up to 60 per minute. And SQS is going to continue to retry failed messages up to a certain maximum receive count that you specify. So a few performance tips. You want to tune your batch size, your visibility timeout, and function timeout. If you're not familiar with those, we can direct you to the documentation on how to configure that. Best practice here is to set the visibility timeout, and that applies to SQS, not on Lambda. So best practice, set the visibility timeout to your SQS queue to 6 times the function timeout. So if your function timeout is 1 second, set the visibility timeout to 6 seconds. And that'll give the function room to retry in case of errors or throttles. All right, so skipping ahead to Kinesis. So Kinesis is generally useful for streaming workloads. So Kinesis is more suited to when you have a use case where you need to provide multiple consumers consuming from your stream. Okay, so for example, you have a Lambda function that does some processing of records, and you have a Kinesis fire hose that pushes raw records into S3. So Lambda is going to provide that first-class integration with Kinesis. All right, so we understand our domain. We've chosen an event router. We've chosen an event store. Now, how do we structure our events to capture the right level of detail for all these various consumers? So this last step in our journey here, step 4, we want to structure these events. So the structure is, deciding how much information do you put in the event. So you can make your event really sparse, or you can include every detail about the event in the payload. Sparse events, seem like good practice, but the problem with sparse events is that the consumers will have to hit the database every time to look up that information. When lots of consumers hit the database, you'll be ending up with some kind of choking point there. On the other hand, if you include all the details in the event, you might run into the risk of values in the event becoming stale or no longer valid if timeliness is a concern in your domain. So finding the right balance is the key to designing the structure of events, and it's important to understand your domain to help you arrive at the right level of detail for how you structure these events. All right. The trade-off with sparse events, you might induce additional unwanted API calls across your microservices to gather event details that might be omitted from that sparse event. So again, you want to look to balance latency and performance with data richness. So this is a bit of an eye chart. This is not intended for you to memorize, but how do you choose between all these different services: SQS, SNS, Kinesis data streams, Eventbridge. It's complicated, right? So we have this flow chart, and these are the kinds of things that we want to keep in mind. And again, this is in the documentation, so we can send out links to this as well. All right. So the star of the show this afternoon is Lambda. And I know everybody's excited to get there. So we're just going to skip ahead a bit and talk about event-driven with Lambda. So we discussed choreography. We discussed orchestration. So now let's talk about Eventbridge consumers. So a target or a consumer is a resource or endpoint that Eventbridge will send an event to when the event matches the event pattern defined for a rule. We learned that earlier today. So in other words, a target processes events. So lots of different targets. You saw that really long drop down in Eventbridge of all the targets that we can send events to. Targets can be EC2 instances, Lambda functions, Kinesis streams, ECS tasks, step function state machines, SNS topics, SQS queues, so on and so on. We learned that a target will receive an event in JSON format. And what we're going to cover in this section is just a focus on Lambda targets for Eventbridge events and how to process and consume those. All right, so for those not familiar, just 100 level here, what's Lambda? So Lambda is our serverless compute service that lets you run code without provisioning or managing servers. So Lambda runs your code on a highly available compute infrastructure, and it performs all the administration of compute resources, including server and operating system maintenance, capacity provisioning and automatic scaling, code monitoring and logging. And with Lambda, you can run code for really any type of application or backend service. All you need to do is supply code in one of the languages that Lambda supports. We have ever-growing language support. We'll touch on that a bit in the next slide. So Lambda, again, our on-demand compute service, and it runs custom code in response to events. So most AWS services will generate events, and many can act as an event source for Lambda. So within Lambda, your code is stored in a code deployment package, and all interaction with the code occurs through the Lambda API. So there's no direct invocation of functions from outside of the Lambda service. The main purpose of Lambda functions is to process events. So these events can be changes in data state, like say an Aurora or DynamoDB database, or requests to API gateway endpoints, or even changes in resource state. So when a function is triggered by an event, this is called an invocation. And Lambda natively supports lots of different languages. So Java, Go, PowerShell, Node.js, C#, Python, Ruby. And more recently, we added a runtime API that allows you to use any additional programming languages to author your functions with a little bit of extra work. Most Lambda-based applications use a combination of AWS services for durably storing data and integrating with other systems and services. So in these applications, Lambda acts as glue between the services, providing business logic to transform data as it moves between services. So this example Lambda function is in Python, but the anatomy of a Lambda function is really pretty much the same across different languages and runtimes. I think if you understand the structure, it's very easy to read a Lambda function in different languages. So the Lambda function file exports a function called Lambda underscore handler. You can name it whatever you like, but this is the naming convention for Python. And that takes an event object and a context object as parameters. So this is the handler function that the Lambda service will call when the function is invoked. And the Python function runtime gets invocation events from Lambda and passes them into this handler. So the function runtime passes a context object to the handler in addition to the invocation event. So the context object contains some additional information about the invocation, the function, and the execution environment. And there's some more information available from environment variables as well. In this example, we return just a simple JSON statement containing an HTTP 200 status code and a JSON encoded string, hello world. It really doesn't get much simpler than this for a Lambda function. So next, we want to look at how Lambda can be invoked, since Lambda plays a crucial role in integrating these event-driven services. So Lambda can be invoked synchronously, asynchronously, or poll-based. So synchronous invocations are the most straightforward way to invoke your Lambda functions. So in this model, your functions execute immediately when you perform the Lambda invoke API call, and then the caller will wait for a response. So what you're most familiar with. Many AWS services can emit events that trigger Lambda functions like API Gateway, Application Load Balancer, and CloudFront. Asynchronous invokes, on the other hand, don't wait for a response. Instead, your invoke request gets placed in a queue in the Lambda service, and we process the requests as they arrive. So AWS services that can invoke Lambda asynchronously are services like S3, SNS, CloudWatch Logs, and there are a lot of other ones as well. Poll-based integrations allow you to integrate with AWS Stream and Queue-based services with no code or server management. So Lambda is going to poll the services on your behalf, retrieve records, and invoke your functions. AWS will manage the poller on your behalf and perform those synchronous invokes. This integration works for Kinesis, SQS, and DynamoDB streams. If you use EC2 or containers with these, you'd have to write a lot of code to efficiently read messages off of those streams. So we take that undifferentiated heavy lifting off of your shoulders. All right, so let's talk about security a bit. You can use AWS Identity and Access Management, IAM, to manage access to the Lambda API and resources like functions and layers. Layers are a feature of Lambda. For users and applications in your account that use Lambda, you can manage permissions in a permissions policy that you apply to IAM users, groups, or roles. And to grant permissions to other accounts or AWS services that use your Lambda resources, you can use a policy that applies to the resource itself. Okay. A Lambda function also has a policy called an execution role that grants a permission to access other AWS services and resources. So at a minimum, your function needs access to CloudWatch logs for log streaming, and that's it. Lambda also uses the execution role to get permission to read from event sources when you use an event source mapping to trigger your function. All right, so a common event-driven architectural pattern is to use a message bus for communication. And this helps with resiliency and scalability. And Lambda asynchronous invocations can put an event or message on an Eventbridge bus for later processing. So we have a feature called Lambda Destinations, and with that you can route asynchronous function results in as an execution record to a destination resource without writing additional code. So an execution record contains details about the request and the response in JSON format. And for each execution status, like success or failure, you could choose one of 4 destinations. You can either send that onto another Lambda function or to SNS, SQS, or Eventbridge. So in this simple example, a Lambda function routes success to another event bus or failures to an SQS dead letter queue. All right, so we're going to briefly talk about orchestration. We discussed choreography, just quickly a word on orchestration, and then we will head into our next lab. All right, so consider a simplified banking system where we want to process a new account. So multiple independent systems require coordination, and events not only have to execute in a specific order, but also be resilient to failure, right? You wouldn't want this happening in your banking system. So contrast this with choreography, where microservices are free to fail independently. Here with orchestration, a failure in one component could fail the flow of the entire use case. So how do we enable orchestration in event-driven architectures? So this is where step functions comes in, and we touched on step functions very briefly in the previous lab, but we're going to dive a little deeper now. So workflows that involve branching logic or different types of failure models and retry logic typically use some kind of orchestrator to keep track of the state of overall execution. With step functions, you use state machines to manage orchestration. So this extracts the error handling, routing, and branching logic from your code, replacing it with state machines declared using just JSON or YAML. And it's common for simpler workflows in Lambda functions to become more complex over time, and for developers to use a Lambda function to orchestrate the flow of their applications. We don't want to do that. So when operating a production serverless application, it's important to identify when this is happening so you can migrate the logic into a state machine out of your Lambda functions. So this enables more complex orchestration use cases across distributed workers. And we have a few resources here. I think we could probably share some of these in chat. But if you want to learn more about Lambda and event-driven, our homepage for all things serverless is serverlessland.com. From there, you can find other workshops like the one we're doing today. That's that second link. You can always revisit this on your own. And we have a step functions workshop and another one called Innovator Island, which is pretty fun. It's a little too lengthy to include in today's event, but we encourage you to check out all of these workshops, including the async messaging workshop there at the end. So with that, we are going to hand this back over to Sam, and we're going to jump into Lab 2, where we're going to get event-driven with Lambda.
Okay, thank you, Mark. So, Mark went over some pretty interesting stuff just now, and we're actually going to take a look at, just how we can achieve some of, what Mark discussed using AWS Lambda, and particularly when you look at AWS Lambda Destinations, right? So I'm going to share my screen here. All right, so you should be seeing my screen. I actually have the the workshop lab page up. So just a kind of level setting here and defining certain things. As Mark mentioned, like when a Lambda function is invoked asynchronously, so Lambda has an internal queue to manage the processing of these asynchronous events. And there's a separate process that actually, reads events from the queue and invokes your Lambda function. So you don't actually have to handle all of that, wiring up of things, and that, frees you up to actually just focus on, your business logic, the things that your code should actually do. So, a common pattern is to actually, use a queue or a message bus for communication. And we actually went over, the use of message buses in the earlier presentation in lab. So what we're going to look at right now is, the use of AWS Lambda Destinations, right? Now, Destinations actually allows you to basically route the results of an asynchronous function call to a dead letter queue or a particular destination that you define. Now this is great because you're actually capturing the entire context of the function execution. So you can capture the request, the event that came in. You can capture the response that was output by the function, and some other metadata such as like the timestamp and the request context and that kind of thing, right? No, you can actually choose one of 4 destinations. You can send that information to another Lambda function. You can send it to SNS. You can send it to SQS, or you can send it to Eventbridge. So what we're going to do, we're going to build on some of the stuff we did in the previous lab to actually, demonstrate how we can actually send this information to, a target to actually get, a fulsome view of the execution context of our Lambda function. So what we're going to do first is we're going to configure the inventory event bus as a successful destination on our orders function, Lambda function, which has already been created for you. So I am now going to jump over to the AWS console and, feel free to follow along here. So I'm going to head over to Lambda. And what we're going to do is select this function called orders function. So here you can see like we have tons of information about this function. We can actually look at the source code here. We can look at, this is a Python function. We can look at some of the properties of the code. We can see the runtime here is Python 3.7, and we can look at configuration and that kind of stuff, right? Now what we're going to do here is we're going to add a destination. So we're going to click on add destination here in the designer view. So what we want to select here is for source, we want it to be in asynchronous invocation. The condition here, we're going to change this to on success. And for our destination type, we're going to select an Eventbridge event bus. And we're going to select the inventory event bus. All right. So once we have all that selected, we're going to go ahead and save that. Now, before we jump on to the other steps, there are a couple of things I want to point out here. The first thing is that your Lambda function is going to need to have the requisite permissions to actually do some of these things. And if you're following along in the the workshop guide, you'll actually see the actual policy here, that the execution policy that the Lambda function uses to operate. So it has access to the put events action, for example, and it has it has access to send SQS messages, and we can actually look at those permissions there, just so we know it's not all happening magically. And if we quickly look at the policy, you'll see it matches the one that's described in the workshop guide. All right. So I'm going to jump back over to the Lambda function here. So we've created a destination. So all on successful execution of this function, all of that context data is going to be sent to or the inventory event bus configured on the Amazon Eventbridge side, right? So the next thing we're going to do, we're going to add a trigger. So we're going to subscribe this function to the inventory SNS topic. So whenever that topic receives an invocation, it's going to actually trigger this Lambda function to execute. So we're going to click Add Trigger here. And under Select a Trigger, we are going to select SNS. The topic we're going to use, let's just start typing inventory here. So that's our SNS topic. And we are going to click Add. So when we look in the design view, we can see that there's an SNS trigger here and an Amazon Eventbridge destination. So what we're going to do now is we're actually going to test that this whole thing works. So to just walk through what's going to happen. So a message containing an EU location is going to trigger the Amazon Eventbridge rule that we configured in the previous lab. So if you recall, we configured a rule that actually filtered for events with an EU location, and we had set I believe it was step functions as the target for that rule, right? So the step functions workflow is going to then send the message to the inventory SNS topic, which is then going to route that message to our Lambda function that we just looked at here. And when that function completes successfully, it is going to, route all of the async invocation information to, the inventory Eventbridge event bus, which is going to output that event to our CloudWatch logs log group. So, a lot of different, pieces working together there, but it, from a high level, it's a pretty, straightforward linear flow. So what we're going to do is we're going to open the event generator. And if you're following along in the guide, you should see a sample event here, event detail. So I'm just going to paste that in. We're going to ensure that we have orders selected as the event bus. And the source is going to be com.aws.orders. The detail type should be order notification. So once you've pasted that detail template in, we're going to click publish. And I'm getting an error here. Okay, not sure why, it's not too much information there. So let me just refresh this. Okay. And there we go. Simple page refresh solved that issue. So our event has been published. And so what we're going to do is, we did talk through like the flow, and the TLDR of it all is that we should, this invocation data for that orders function, Lambda function, should end up in a CloudWatch logs log group, right? So we're going to head to CloudWatch logs. And we're going to look at the inventory log group. And as you can see, there's a log stream created here. So if we look at this log stream and expand this JSON, snippet here, we're going to see a lot of information. So this is essentially, all the information associated with the asynchronous invocation of that Lambda function. So we have the request payload. And this is essentially what the Lambda function received from SNS when it was called. We can actually see the message itself that was sent, which is what we published from our event generator tool. And we can also look at the response payload. So this is actually the response that the Lambda function, output. So as you can see, we quickly configured, a destination for this Lambda function where, data is output once that function executes successfully. All right. The next thing we're going to look at is error handling. So we're going to look at adding a destination that actually, sends this context data to a queue in the event that the Lambda function did not execute and complete successfully. Right. Before we move on, just want to check in here to ensure that everyone is following along and that there are no issues. So, if we're all good, if we're all on the same page, just, indicate in the chat that, you're following, thumbs up, or yes is perfectly fine. Okay, so I'm going to move on then to the error handling section of the workshop. So as Mark mentioned in his presentation, AWS Lambda has support for, what's known as a dead letter queue. And that is essentially a queue where, upon failure, everything is just basically sent to that queue. And Lambda has had support for this, for some time now. There is a preferred way of handling, failure, logging failure and collecting all of that data. And it is to essentially do pretty much the same thing we just did, which is create a destination on that function. But in this case, we're going to, collect the data on failure, right? And we can, push that to an SQS queue and, do further processing with that to kind of figure out what went wrong, and how it can be resolved going forward. So I'm going to jump back to the console. I'm going to head back to Lambda. I'm going to select orders function. And as you might have guessed, we are going to add a destination. This time we're going to leave the source as asynchronous invocation, but this time we're going to change the condition to on failure. All right. For the destination type, we're going to select SQS queue. And for destination, we're going to select orders function DLQ. All right. Again, this queue was already created, beforehand for you for the sake of simplicity. All right. Now, if you might recall that I showed you in a previous section, the permission configuration to show that the function has the requisite permissions to actually push messages to that SQS queue. Right. So we've added that destination. So if this function fails, it's going to send a message with all the context data to that Amazon that SQS queue. All right, so now that we've had that configured, we can see we have multiple destinations here. We have one on success, one on failure. We can see the different targets or destinations then for these for the configuration here. And we're going to go ahead and test the end-to-end functionality here. So to just walk through what's going to happen, we're going to publish another message with an EU location, and that's going to be routed to our step functions workflow. But this time we're actually going to add a flag called force error. And you might see that template if you're following along using the workshop guide. So what's going to happen is the Lambda function is going to receive that that message via SNS. Once it's invoked, it's actually going to look for that flag and it's going to fail if the force error flag is actually set to true. So let's head back to our event generator. And we're going to paste the message there. As you can see, there's a force error flag added. And we're going to publish this. Ensure that your event bus, your source, etc. hasn't changed. It's still orders, com.aws.orders, and order notification. So I'm going to publish this, and you can see there the event was published successfully. All right. So we're going to look at the function itself. I'd like to just show you what's in the code of the function. So as you can see, this is a Python function, and basically what this is doing is looking for the force error flag to see if it's set, right? And it's going to raise an exception if that flag is set to true. So we're going to head over now to SQS to see if our message actually arrived at the intended destination. So we're going to select the orders function DLQ. Q. Okay. We're going to hit send and receive messages. And as you can see, there is one message available here, right? We're going to hit pull for messages. I'm going to grab this message, and here we are. You know, we have all the context information from that asynchronous function invocation. We have the request payload. We have our response context and our response payload. So all the data associated with the function. As you can see here, there's actually a stack trace. Now, this is one of the reasons that, you know, using destinations over using a dead letter queue is the preferred method of, you know, kind of handling this kind of situation, because you have the option like of, you know, when you use a destination, you actually get the stack trace from the function to see what actually went wrong. All right. And there you have it. So we have very quickly configured two destinations on a Lambda function. So we showed what happens on success. You know, we you know, configured a CloudWatch log group to collect that data. And on failure, we configured, well, we didn't configure, the queue was already there, but we set up the function to actually push that message, that context data about that particular invocation into an SQS queue. And, you know, we're looking here at the data. And again, you could actually have another service, or, you know, we configure something else to actually pull this queue, grab this data to actually investigate errors in your application, to find, you know, failure points, and to, you know, act on that data as you wish. So we have come to the end of the event driven with Lambda lab. Are we all caught up? Are we all on the same page?
All right, so I just published one more poll. Lets us know the status check of everybody that's still here. So if you've completed the entire lab, or if you are still working on 3.1 or 3.2, just let us know. And then otherwise we will continue on, where Robert will explain a couple of real world applications and how ClearScale helped a couple of companies, as well as an AWS survey where you can provide our some feedback so we can improve on our next workshop as well.
Hey Sam, Deepti has a problem where the event ID is blank.
Okay, so I see. So is this happening when you're hitting publish in event generator? Deepti? I mean, if that is the case, you know, try refreshing the page and actually ensuring that all the you know, right. So just first of all, refresh your page and ensure that your event bus is set to orders, your source is set to com.aws.orders, and your detail type is set to order notification. And also just verify that you're still actually signed in to the event generator tool. You should actually see a sign out link here if you're signed in. Okay, so according to the poll, we still have a few people still working on the destination section. Have you run into any particular issues? Just feel free to use the chat. We'd be happy to help.
So we'll work through a couple of these chat comments, give you guys some time to wrap up, and then we will move on here in call it 5 minutes or so. All right. If nobody else has any comments within the chat window as they're trying to wrap up, I'll go ahead and have Robert jump over to the slides portion where we can go over both Reach Local and I believe RF Smart. Robert, whenever you're ready, just remember to unmute your mic.
Yeah, good reminder. I'd already started talking. Gets you every time. All right, so both of these projects I want to talk about are clients we've had in the past, and where we've implemented serverless technologies in to help improve or solve a problem that the customer was having. And this first one here, Reach Local, had a client reporting application that they were looking to, really just improve security. The clients need to access data in this reporting application. But also they wanted to really improve the scalability and the technology that they were using, and go to a more serverless model to help with both scalability and cost efficiency. So we ended up putting in place a model using managed API gateway, Lambda functions as the compute, and using code pipelines for them to publish their data. And so in the end, the client had a new architecture that delivered data in a secure manner, but also had other benefits, such as being an open architecture, which allowed them to their customers to access this data in a standard format. It was very flexible, using APIs that could be customized for specific data sources and report types. It had organizational stability, whereas every new API reporting service could be worked on by different engineers. They weren't stepping on each other's toes. And it also had scalability in the delivery side of things, depending on the size and the complexity of the reports or the demand. New resources could be scaled up and added and to handle those needs. And so if you'd like to read this case study in more detail, it's on our website, and you can find it there. The next one that I wanted to go through quickly was a company called RF Smart, who wanted to put in place a new environment using best practices and modern DevOps principles, and also to enable some DR capability. And so for them, we came up with, again, kind of a serverless approach. We put in some new CI/CD in place and put in a blue-green deployment process using serverless, and also using Route 53 and some environment checking, put in place a DR that they could fail over to if it detected that the service was not running. So again, here, kind of using infrastructure as code, adding some modern approaches to deployment, and kind of refactoring their existing applications. We allowed them to be able to make changes on the fly very easily and reliably, and to be able to push those changes out in a faster and more reliable way. So again, as with the previous one, there is a case study on our website that goes into this project in more detail, along with architecture diagrams and kind of all the details about what we put in place. Next, I wanted to inform you that ClearScale has several serverless offerings that are available, and these kind of range in scope from 1 day to multiple week engagements. The first one here is just called a serverless workshop. So here, here you're going to learn the value of serverless computing and how it optimizes your application reliability and performance. Kind of discover whether or not this would be a benefit for you. So, kind of just gaining clarity on serverless, possibly identify a business issue, and then possibly try and define a potential proof of concept to work on. The next one is a serverless assessment. Here, it's kind of taking it to the next level, is determining a workload of yours that could be migrated to AWS Serverless, kind of evaluate that architecture more closely, develop some criteria, some success criteria around that proof of concept, and start building an understanding of those serverless services needed for that, clarify your business requirements, assess your readiness for a POC, and then align on any prerequisites, goals, and again, those success criteria. And that's kind of a 2-day engagement. Next option would be the actual proof of concept itself. Of course, this one can vary widely based on your actual use case. It has 8 to 10 weeks here. Sometimes it can even be less than that if it's something fairly simple. So here you're actually going to implement the modernization project. So kind of in the design phase and even refactoring code. So you start out with just clarifying the requirements, then work on refactoring your code, stabilizing that code for serverless, and then deploy it into a serverless environment in AWS. I should also mention that with projects like this, oftentimes there are AWS funding programs that we can take advantage of to help offset the cost of working with a premier partner like ClearScale. And so definitely we can discuss those if you want to contact us for more information on those. And then the final one here is kind of a full-on serverless refactoring project. And with this one, you're ready to proceed with refactoring the application based on success of maybe either a proof of concept you've done internally, or if you had gone with the previous offering, the proof of concept there. So here you want to clarify those serverless requirements again for multiple applications usually. Maybe in the proof of concept you only did a single application or a single use case. Here we're talking about a complete solution. Refactor and stabilize the code for each one of those applications or opportunities, and then again deploy those as part of this engagement. And so again, these are all kind of just examples of the size of projects that we work on all the time. And if you're interested, reach out to us to learn more.
Excellent. Thank you, Robert. Now, before we jump over to the Q&A portion where we'll answer questions both from the chat as well as a couple of common questions that we receive, we really need your feedback. So I'll be pushing out a pop-up right now. It should show up on your screen, and it simply asks for your feedback. So this is a 60-second survey. If you would just open that up, let us know your thoughts on today's presenters, the content, how we can improve, and just your overall thoughts. Certainly, we can apply that feedback just like we did previously for an even better and bigger workshop in the future. So I'll give everybody just a minute to go through that quick survey, and then we will move forward to the Q&A portion of today's workshop. All right, I'm going to go ahead and move forward, but please feel free to file plenty of questions into the chat. But for our first question, just want to remind everybody that we have a bevy of talent here. So plenty of solution architects, engineers, support staff, again, there's going to be very few questions that we're unable to answer. And if we can't, we'll find the answer for you. So one of the questions I have is, how does Amazon Eventbridge relate to CloudWatch events? Mark, Sam, either one of you guys want to jump on that?
Yeah, I'll take that. It's Mark. So it's basically it's based on the same technology. So before there was Eventbridge, there was CloudWatch events, and as we saw earlier in the presentation, we can create rules. You saw the example of scheduled rules. So for cron jobs, and that feature, along with many other features, has made its way into what is now branded as Eventbridge. I'm sure there's a lot more to it. I think Veda, if you're still on, Veda is definitely our Eventbridge expert, and I'll put her on the spot to give more color.
Hey, Mark. Yeah. So, yeah, as Mark said, CloudWatch events sort of does that cron job for you. And we extended that in the form of Eventbridge. So it is sort of, if you try and try to create a CloudWatch event, it's sort of like the Eventbridge under the hood. And we extended that cron job kind of capability and sort of added the SaaS partner integrations and sending custom events from your applications into Eventbridge.
Excellent. A follow-up question on Eventbridge. What is Eventbridge Archive and replay events?
Sure, I can take that. So with event-driven architectures, often, as Mark said in his presentation, an event is something that signifies some event that has happened in the past, right? And you kind of are acting on it. Often there needs to be a way to sort of keep an audit log of what all are the events that happened in the past, and what is the set of events that put your application into a state what it is in right now. So to sort of have that audit log, and sort of hold on to those events where, say, if you have a new feature that you're developing and you want to push that feature to production, but you want to be able to go back in time and sort of rerun all those events for this new feature, right? So you need to be able to store those events. So that's what Eventbridge Archive Replay is useful for. You can sort of push a new feature to production, rerun all the events that have happened in the past, and sort of get that data for the new feature as well. Or if you simply have a bug in one of the microservices and you want to sort of fix that bug and then rerun all the events that have happened in the past, that could be a useful feature as well. So Eventbridge will, if you turn on Archive Replay, Eventbridge will archive the events, and when you want to replay, you can replay those events as well.
Excellent. Robert, I believe this one's for you. Earlier, you mentioned that that ClearScale has a handful of AWS competencies. What are these, and why are they important?
You put me on the spot here. So first, I'll talk about the competencies in general as I'm looking at the latest number, because those are changing. But competencies are a kind of a accreditation that AWS offers to its premier partners. And ClearScale is a premier consulting partner, which is the highest tier that AWS has. And you earn competencies by proving knowledge around a certain topic. And that's done through things like certifications of our staff, training of our staff, customer experience around this topic. And these are all verified. And so it's not just something where we submit some paperwork and shake hands and say, all right, you've got this competency. These are actually things that are verified through customer experience and audits from AWS. And so I believe, and I could be wrong, I believe we have 11 competencies now.
Yes.
And I say that because we often are working on new ones. But those 11 competencies are the migration competency, DevOps competency, Microsoft workloads competency, healthcare competency, education competency, data and analytics competency, SaaS competency, nonprofits competency, IoT competency, mobile competency, and machine learning competency. And so those are the current 11. And like I said, we are always working, striving toward attaining more of those.
Yeah, and just to reiterate what Robert said, I mean, these are very labor intensive, and I know that from the marketing side because we certainly help with the application process, grabbing the resources, and there's all kinds of pieces that we have to put together for the review from AWS. So it is one of the, I think, many calling cards of ClearScale is that certainly if you come to us for serverless or for migration, you can trust that we have a very wide range of knowledge in AWS services. So, we can help in just about any and every capacity as a premier partner. But is there anything else we should add to this? Mark, Veda, anybody? Awesome. I think we covered it pretty well. All right. So a couple other questions. AWS Lambda. When should I use Lambda instead of EC2?
I would say always use Lambda. Right?
Well, maybe we could talk about when not to use Lambda. How about that?
That seems like a fair question too. Yeah.
So the first constraint on Lambda is generally around the amount of time it can run for. So there's a hard limit of 15 minutes on how long a Lambda function can run. If you have any long-running processes that would require invocation times beyond 15 minutes, Lambda would not be a good choice there. There are ways to decompose an architecture to circumvent that, but that's like on a per use case basis. There's limited file system and limited memory. Obviously, there are it depends in air quotes, but I would encourage you to reach out to your AWS account manager, have a conversation with solutions architect, reach out to ClearScale, and we could definitely dive into those use cases deeper and come up with a solution for you.
Great.
Yeah, in addition, to add to that, if you have like a workload which is running constantly, right? Not super bursty, but you have like a predicted, traffic pattern which is running constantly 24/7. Then you're probably better off using an EC2 instance. Lambda would probably be turn out to be expensive. But on the other hand, if you have like a bursty workload, unpredictable traffic pattern, and you don't want to manage your own infrastructure for that, then Lambda is a good fit. Again, it should fit within that 15-minute. Each transaction that comes in can run within that 15-minute time frame.
Perfect. And last question I have here, how do I monitor or troubleshoot failures in a Lambda function?
I'll take that. So there's a couple of observability tools available to you for Lambda. So the first one is going to be CloudWatch logs. So every invocation of a Lambda function, you can write a log out to CloudWatch logs, and that can give you some insight into perhaps any exceptions that might be thrown from your functions. There's also a bevy of metrics available in CloudWatch Metrics that you can use to monitor the performance of your Lambda functions. Perhaps you might be under or over provisioned. We have another service called AWS X-Ray, which can give you insight into latency between services that Lambda might be interacting with. Am I forgetting anything, colleagues? Those are like the top 4 that I think about.
Yeah, you covered it. X-Ray, because it's harder to sort of trace an end-to-end application, more so when it is distributed. When you're using serverless services. To tie it all together, X-Ray gives you a nice service map, to view the entire end-to-end application, and you can even dive deep and trace a particular transaction. Or you can do much more, like if you want to aggregate a set of transactions and get some metrics out of it, X-Ray is really helpful. Another way is you push your logs from your Lambda functions to CloudWatch using what is called embedded metric format. You can write custom metrics and get useful information out of those metrics as well. So CloudWatch, X-Ray are probably your best friends for observability and monitoring.
Excellent.
I have one more to add to the list, Veda. It is CloudWatch Lambda Insights, which was a recent addition, which kind of brings everything you said together. So that's another good option.
Excellent. Thank you. All right. Any closing statements from our presenters? Certainly a big thanks to Sam and Mark and Robert for working on all these materials.
Yeah, thanks everybody. Thanks for having us today. I know that it is a large chunk of time out of everyone's day. Really appreciate you dedicating that to us, and we hope you all learned something today.
Excellent. Well, we're up against the clock at this point, but should you have any questions, please feel free to schedule a consultation with our team by simply using the pop-up in the lower left corner, or by reaching out to sales@clearscale.com. Again, many thanks to Robert, Mark, Sam, Veda, the entire AWS team for their many hours of preparation and promotion. We'll be following up with a copy of today's presentation, as well as a link to an on-demand copy of this workshop within the next 24 hours. Your credentials, again, are going to be available through the day. So if there's anything you want to jump in and complete, feel free to do so. We hope you have a great rest of your week, and we look forward to discussing serverless with you very soon. All right. Appreciate it, everybody. Thank you so much.